Okay, so for this video, I'm going to be talking about eigenvalues and the time-independent wave function. Just because when I first learned about this, I was a little confused, and hopefully this should be like a quick, short video just to clarify some things. So, what is an eigenvalue and what is an eigenfunction? These terms are obviously like super confusing. So I think it's better to take a step back and ask like, what is an eigenequation? Which is something that really doesn't get talked about in quantum physics courses. So an eigenequation is an equation essentially of this form right here. Now let's break this down a little because this might seem a little complicated, but essentially you have an operator being applied to a function to get the same function multiplied by some constant a, where a is like a real / imaginary number, but it's constant. So that's pretty much what an eigenequation is. In any equation where an operator is applied to a function to return that function multiplied by a scalar. And the scalar is just some constant number. So an operator is pretty much just a function that acts on functions. Like the derivative is an operator. You'll see a bunch more operators, and in the next page I'll show you the Hamiltonian operator, which is used, but an operator is just a function that acts on a function to change it. Now, so the eigenvalue and the eigenfunction, what are those? So the eigenfunction is the function that you're solving for here. It's the f of x. And the eigenvalue is the scalar. So just to go over this one more time, you take some operator and then apply it to a function, and you get back some constant multiplied by that function, and the constant is the eigenvalue and the function is the eigenfunction. So let's look at the time-independent Schrodinger equation. So in the time-independent Schrodinger equation, you take the Hamiltonian operator, which some of you might not have seen yet, but you actually have seen it, you just haven't seen it in this form. Apply it to the time-independent function to get E, which is the energy value, which is a constant, multiplied by the same equation. And the Hamiltonian is this form, or is this. So pretty much when you apply the Hamiltonian to this function, all you do is you just pretty much plug in the function here, or like multiply it through almost, and then apply the derivative. So plug the psi function into the Hamiltonian, and this is what you get, equal to e of psi x. So the eigenfunction is just going to be any solution for psi of x that satisfies this equation for some value of e. And this is more of a math concept than a physics concept, but we're using this math terminology to describe what we're doing here. So it's just important to know it. And for the wave equation, something that you should know is there's going to be multiple psi of x's that correspond to e's, and they're usually denoted psi n of x and e of n. So hopefully this was a quick video to just shed some light on this topic and explain what exactly eigenvalues and eigenfunctions are in relation to the Schrodinger equation, especially the time-independent Schrodinger equation. Hope this was helpful.